NASA just announced the discovery of 500 new planets.
Alien life on another planet.
Found to potentially have oceans and atmosphere with carbon dioxide.
We've always dreamt of discovering alien life, and now, thanks to the James Webb Space Telescope, JWST, we might be one step closer. It's all about a mysterious exoplanet named K2-18b, located in the constellation Leo. But is it really a potential habitat for extraterrestrial beings? K2-18b is the star of our show, orbiting a dim and cool red dwarf star known as K2-18. This remarkable exoplanet was the first to be discovered in this star system. However, its proximity to the star creates some unique challenges. To match Earth's level of sunlight, K2-18b has to cozy up much closer to its star. Now here's the jaw-dropper. K2-18b is just a mere 124 light-years away from us. In astronomical terms, that's practically next door. But what's it really like in this distant world? We might not have snapshots of the planet, but we can piece together some crucial information. Let's talk illumination. K12-18b basks in starlight far differently than Earth does. It orbits its star at a mere 16% of the distance between the Earth and the Sun. This, my friends, is a light recipe for potential life. But wait, there's more to the story. In the world of cosmic energy, it's all about the star's power output. K12-18, our red dwarf star, radiates only 2.3% of the Sun's energy. So you might be wondering, can K2-18b really support life as we know it? Well, the conditions are surely different, but they're not out of the question. With the right mix of chemistry and planetary magic, this mysterious exoplanet might just be a hidden treasure trove of alien wonders. The JWST has also spotted some intriguing chemical markers on K2-18b, which are associated with living organisms here on Earth. However, these are just vague indications. It's like looking for footprints on a distant beach. They might suggest someone's been there, but they won't tell you who. K12-18b receives about 1.22 kilowatts kW of solar power per square meter. That's quite similar to Earth's 1.36 kilowatts, despite the dimmer star. How is that possible? Well, the secret lies in proximity. K2-18b cozies up close to its star, compensating for the reduced energy. Now, when we talk about life on other planets, there's a fancy term in the space lingo called the habitable zone. It's the region where the average surface temperature is just right for water to exist in its liquid state. And you know what? In 2019, the Hubble Space Telescope gave us some good news about K2-18b. It showed signs of water vapor, hinting at the possibility of massive oceans. The atmosphere of K2-18b resembles a chemistry set for potential life, with the presence of carbon dioxide, methane, and a particularly enigmatic compound known as dimethyl sulfide, DMS. DMS is a molecule composed of carbon, hydrogen, and sulfur atoms, and its significance lies in its association with life on Earth. On our planet, DMS is primarily generated by certain types of algae and some marine bacteria. It's essentially a made-by-life label, indicating its biological origin. The discovery of DMS on K2-18b has scientists pondering whether this molecule might also be a product of living organisms in that distant world. This revelation adds a layer of complexity to the search for extraterrestrial life. While the presence of DMS on K2-18b is an exciting clue, it is not conclusive evidence of life. Further research and observations are necessary to confirm the existence of life on this exoplanet. Could the exoplanet K2-18b be our celestial neighbor with extraterrestrial life? The hints are intriguing, but understanding this isn't as simple as it might seem. To explore a planet's atmosphere, we rely on a method involving light from far-off sources, such as stars or galaxies, passing through it. This light encounters different chemical compounds in the planet's atmosphere, and it's like these compounds are cosmic detectives that absorb the light in specific ways, leaving us with clues to decipher. Now, let's simplify this complicated process. Imagine you have a clear glass tumbler. When it's empty, you can easily see through it without any problems. But what happens when you add water to the tumbler? You can still see through, but there might be a slight distortion, somewhat like the hydrogen and dust clouds we find in space. Now, think about pouring in some red food dye into the water. This represents the main chemical in a planet's atmosphere. But here's where it gets tricky. Most planetary atmospheres are like a mix of many different chemicals, like a cosmic cocktail. It's as if you poured not just one, but maybe 50 or more various colored food dyes in different amounts into your tumbler, and now you're trying to figure out how much of one specific color is in there. It's like solving a celestial puzzle with lots of room for interpretation and potential mistakes. To make things even more challenging, the light passing through the atmosphere also carries signals from the star's own chemical composition, adding another layer of complexity to the analysis. Let's rewind for a moment. Not too long ago, there was a big buzz about the possibility of life on Venus. Observations hinted at the presence of phosphine gas, a substance associated with microbes. But then came the plot twist. Several studies debunked this theory. If there is confusion about what's happening in the atmosphere of a neighboring planet, Venus, think about the complexity of analyzing a distant world like K2-18b, which is light years away. It's like comparing a stroll in your neighborhood to a marathon on another continent. The odds of life on K2-18b are like a lottery ticket, slim but not impossible. It's crucial to remember that these findings won't make folks suddenly believe in little green aliens. What they will do, however, is showcase our ever-evolving ability to peek into far-off worlds and gather more cosmic clues. Now, let's talk about the cosmic superhero in this tale, the James Webb Space Telescope, JWST. It's not just about snapping stunning space selfies, it's a data powerhouse. The JWST isn't just our paparazzi of the universe, it's our ultimate cosmic detective. By revealing which exoplanets have water and which don't, it's like peering into the recipe book of Earth's formation. This advanced space observatory is named after James E. Webb, the second administrator of NASA, and is a joint project of NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The JWST specializes in infrared observations, which enable it to see through dust clouds and study objects and phenomena that are challenging to detect in visible light. Positioned at the second Lagrange point, L2, about 1.5 million kilometers from Earth, the telescope offers a stable and unobstructed view of the cosmos. Equipped with a suite of scientific instruments, including a near-infrared spectrograph, NIRSpec, near-infrared camera, NIRCam, mid-infrared instrument, MIRI, and a fine guidance sensor / near-infrared imager and slitless spectrograph, FGS/NIRISS. The JWST is a versatile tool for various scientific observations. This cosmic detective's primary mission is to study the formation and evolution of galaxies, analyze the atmospheres of exoplanets, investigate the origins of stars and planetary systems, and explore the early universe. The JWST features a colossal sun shield with 5 layers, roughly the size of a tennis court, to shield its instruments from the sun's heat and light. Well, the JWST has faced significant delays and cost overruns during its development. It is considered one of the most ambitious and promising scientific projects. It's poised to revolutionize our understanding of the cosmos, revealing hidden secrets about distant worlds and offering valuable insights into Earth's own origins. This space observatory is not just a paparazzi capturing cosmic images. It's a vital tool in the quest to decode the universe's celestial recipe book. But here's the real cosmic twist. These discoveries aren't just about this one alien hopeful, K2-18b. They unlock doors to understanding the great gas giants in our own cosmic neighborhood, like Jupiter and Saturn. By studying these far-off exoplanets, we're like cosmic scientists, gleaning insights into their atmospheres and how they work. Now, let's talk climate change, cosmic style. By identifying CO2 levels on these alien worlds, we're cracking the code to the ultimate greenhouse effect. What we find here could help us understand how an extreme greenhouse effect might transform a planet. As we wrap up this eye-opening journey, remember this: the cosmos is full of surprises, and our journey to unlock its secrets continues. K2-18b may or may not be home to alien life, but the quest for knowledge never stops. Whether it's understanding Earth's origins, peering into the atmospheres of distant giants, or deciphering the cosmic climate, every discovery takes us one step closer to understanding the great space puzzle. So, what do you think? Share your thoughts in the comments below, and don't forget to hit that like button if you've enjoyed this video.